Hello,
Okay, hello, good morning.
good morning. How are you?
Okay, I am fine. So I am waiting some time, some 1 minute. So then
Okay, okay.
other parts will join. Okay, okay. Uh, okay, okay. So can you hear me? Hello. Okay. So now we will start our today's session. Okay, can you hear me now?
Yes, it is audible.
Okay. So now we'll start our today's session. So I simply share my screen. Wait a minute. Okay. So I hope can you see my screen now?
Yes.
Yeah. Okay. So hi and welcome to the 7 days online training session on Google Earth Engine platform. From beginners to advanced on remote sensing analysis, we already covered our fifth number of classes. So today is our sixth number of class. So mainly today we'll try to discuss about the image classification. So for this, I am course coordinator, and and this is our full course content. We completed all of the course content within the 7 days. So we already covered our fifth days. So today is our sixth number of class, and today class is that. So mainly today we'll try to discuss about that how you can easily make the land cover classification map using the machine learning. So mainly in this time here I use the supervised machine learning. Then how to make the LULC classification chart. Suppose you want to make the chart, how many area you want to make a area chart. So how many build up area, how many barren land, how many or other classes is available. The area we can also make the area chart. Okay, represent the area in chart, and then calculating the area in LULC. We can calculate the
I
every
don't
classes
see your
area.
screen.
Yeah, can you see my screen?
No,
Why?
no, no.
Is not visible now.
It's not visible.
Why?
Share it again, it will be more.
I share again. Wait a minute. Now can you see my
Yeah,
screen? Now
yeah,
can.
no, it's okay.
Okay, okay. So okay. So basically, in this time, I will try to discuss about that how we can easily make the land cover classification map using the supervised machine learning method. Then how to make the LULC classification chart. Then how to calculating the every is classes and how to add the legend. Okay, so in this time so first of all we should know what's the process when you want to make the land cover classification map. What is the process? So this is the, in this time I will try to discuss about that what is the process to make the land cover classification map in Google Earth Engine platform. And this is the same process for any image, any area. When you want to make the land cover classification map, you should follow the step by step, then it will be okay. So first of all, you need to selecting your region of interest. Suppose you want to make the land cover classification map any region. First of all, you need to import your shape file in Google Earth Engine platform. Okay, then you need to choosing and filtering the image collection. Suppose you want to use here the Landsat or Sentinel, you need to choose your image, then you need to filter your image, okay, according to the time period, according to the image properties, according to the different factor you want to filter your image. And choosing your image, this is the second process. Third process is that you need to collect the training point, you need to collect the training point for every each classes. So this is the supervised classification method. So that's why we need to collect the training point from the satellite images. We can take the training point. Suppose this is the training point for the water body, suppose this is the training point for the urban area, suppose this is the training point for the build up area. We just collect the some training point like this. Then we need to merge all of the training point, we need to merge all of the training point together. So we make the merging function for merge all of the training point. After this, from this training data set, we take the make a training data set. So mainly in this training data set, we will try to add all of the band value. Suppose which band I want to use here, I take the band value for every each point. Okay, so it's called the make data set. Okay, from this data set I want to create the classifier. So here Google Earth Engine has a lot of classifier will be available here. It can be random forest, it can be the minimum distance, it can be classification and regression trees, it can be super support vector machine. Okay, so there are the lot of classifier will be available here. We can classify the image and create the classified image. Okay, then we need to display the result. Okay, and then we also try to make the accuracy assessment. What is the accuracy assessment for our map? And then we also try to measurement the accuracy. Okay, from the confusion matrix table in Google Earth Engine platform. So basically this is our course content. I will try to show you all of that step by step so that you can easily understand, and also calculate the area for each classes. Okay, so this is the step by step. When you want to work, then you can easily make the land cover classification map for any region. Okay, so we'll try to show you that practically. So that's I simply open my code editor and try to show you all of the things. Okay, so first of all I simply open my code editor. Also you can see another thing is that, so you can see this is the another small project of the land cover classification map using the Google Earth Engine platform, and this is the code link. Also you can see this is the another map for the Dhaka city land cover classification map. Okay, so in this time I also try to show you that so that you can easily do this. So I simply open my code editor. Okay, so in this time our first step is that we need to import our shapefile. Which area I want to make the land cover classification, I simply import. Suppose in this time I want to work with the Dhaka city. Okay, so I simply import the Dhaka city shapefile. You can see this Dhaka city shapefile is imported and default variable name is the table. I simply change it and give the name is that RY. Okay, no problem. And then in the second step is that I need to filtering and displaying and selecting and filtering my satellite imagery. So first of all I simply use here the this image. I simply go to the browse data catalog. I want to use here the Landsat image. I simply click on the Landsat image collection, and then I want to work with the suppose Landsat 8 top of atmospheric. This dataset I want to use for making the land cover classification map. So in this time I want to import this dataset and filter this dataset. Okay, so I simply open, just copy the Earth Engine snippet and paste in my code editor, and then take a variable name. suppose this variable name is the L8. Okay, then I simply store. You can see in this time my full Landsat 8 top of atmospheric, this satellite collection is stored in a variable L8. In this time I want to filter it. Okay, so I simply take a variable and give the variable name is the image. So I simply use here the L8, then I simply use here the filter bounds function. So it will be intersecting with my region of interest. So in this time my region of interest, you can see this is the ROI. Okay, then I also want to filter this image specific metadata. So I simply use here the filter metadata, and then I simply use here the cloud cover. This is my image properties name, cloud cover, and this cloud cover I want to choose here the less than 1%. Okay, and I want to created the land cover classification map for suppose year of 2020 or 2021 or any specific time what you need. So I simply use here the filter date function, and I simply put here the year of 2000, suppose 20, 1st January from year of 2020 December 31. Okay, so I simply put my specific time period. I want to check how many images will be available here. I can simply use the print function and then call my variable image and use here the size function and then click to the run. We can get the 7 images. Okay, in this time we can use the another method is that suppose you want to make the land cover classification any specific only for the single image. Suppose you can see here I can get the total 7 images, and this total 7 images is captured the different time of the year. Here you can get all of the time period, you can see. So here you can see this is the first image is captured a year of 2021 11th February. You can see this is the another image captured the 26th January. Okay, 11th February. Okay, so here you can see a lot of images. Suppose you need only for the single image. Suppose you want to work only for the image which image is captured year of 2020 30 March. You want to work with this image, so then you want to easily work with this image. So you can simply copy this image ID and then you can easily work with this. Okay, so if you want you can also possible for work with the any single date image. So here you can get all of the date will be available here. Which date image you want to need, you can simply copy this ID and work with this. So we already covered this part when you want to filtering the Landsat images, how you can easily display the image in here. So in this time I want to created that I want to created the total 7 images median pixel value. Okay, so I want to created the total 7 images median pixel value. So for this I simply use here the median function, median, and then it will be clip with my shapefile. I simply use the clip with my shapefile is that ROI. Okay, so in this time I want to show the layer. I simply use here the map dot add layer, and then I simply use here the image. This is my object, and I want to add here the visualization later. So I simply run this code. One layer will be added here, but I did not see the image. So for this I want to use here the map dot center object. Okay, then I simply call this is my ROI and put here the zoom level 10 and then click to the run. So now it will be display the image. Okay, but this image is not more significant because I did not add the proper visualization. Okay, so in this time I want to add the visualization, then we can easily understand all of the feature, all of the things easily. So I simply go to this here visualization parameter. I want to use here the true color composite or natural color. So this is the red band, then green band and blue band. I also increase the stress 98% for better looking and click to the apply. So now you can see this is our satellite imagery we can get for year of 2020. Okay, in this time I want to use this satellite imagery for making the land cover classification map. I also import this visualization parameter, so simply click on this here. So I simply copy, okay, and then simply paste here. Okay, I also put the layer name is that, suppose true color composite. I simply put the layer name. So now this layer name also will be showing in here. You can see true color composite in here. So in this time, this is my second process I already done. First process is that selecting your ROI. Second process is the choosing and filtering your image. Okay. Now I will move to the third process. Third process is that you need to collecting some training point. So it is a supervised classification. So that's why we need to set some training point. Okay. Suppose I want to add the training point from here, from this satellite imagery. Suppose some classes. So which class I want to make the land cover classification map. I want to set these classes. So when you want to take the training point, so mainly we can use here the different types of vector format. We can use the dot marker. Okay, also you can see the vector line or draw line, but in this time I will use here the dot marker, and then I can take the training point for every classes. So I simply click to here. You can see a new geometry will be added here. Also you can see the new geometry is also added here. So in this time I want to simply click to here. Suppose first time I want to take the training point for the water. So I simply use here the name is the water. You can use any name. So I simply use here the water, and import as it is the feature collection. And property, you need to use here the property because this property is neat, and this property name will be same for all of the classes. Because when you want to take the urban body, then you can use here the same property name. When you take the training point for the build up, you can take the same property name. Okay, property name will be same but value will be changed. So I simply take the property name is the class. You can take the any property name like a variable. Okay, and I simply put the value is the 0. Okay, so I simply take the property name is the class and value is the 0. So it means that when I take the training point for the water, suppose I take the training point for the 100 training point for the water. So this 100 training point value is 0. All of the training point of the water, this value is the 0. So I can easily identify when I see the training point is showing the 0. I automatically identify this is the training point for the water. And the same thing when I want to take the build up area, I take the value for the 1. Then it will be identify this value is the urban water value is the for the what 1. Okay, so in this time I simply do this and then click on the OK. Okay, so you can see also it will change. So in this time I want to take the training point. So this place I already know better where is the water, where is the vegetation, where is the build up area. Okay, so I already know better about this place. When you want to make the land cover classification map in the unknown place, suppose you will not go this place ever, so then how we can do this? Then we also do for the things another way. I also try to show you this in the later, so just a minute. So in this time I want to try to make the land cover take the training point for the water. So I can see this is the water body. I already know this is the water body, so I simply take the water body. And this training point depend on your region. Suppose your region is the big or your region is the small, then you can take the training point. So suppose you can see this region is not so big, so I think this time we can get the training point for each classes 30 or 20. It's better. So I can simply take the training point for the water body in here. Okay, you can see I take the training point for the water body. In the next time I also take the water another training point for built up area, okay, or urban area. Okay, so for this I simply click on the new layer, then simply click on the edit properties layer, and then in this time I simply put here the suppose I can simply put the suppose this is the build up. Okay, I simply put the name is that build up, and geometry feature collection property will be same. I can simply put here the class. Okay, and value in this time I set the value is the 1. Okay, so in this time all of the build up training point it represented the value is 1. Okay, so I simply take the click to the OK. and then I simply take the, suppose this is the build up area, this is the lot of build up area, so I simply take the build up area. Okay, so in this time here you can say I take the some training point for the build up area. And suppose you want to need you want to also classify the vegetation, so for this you also need to take the for the vegetation training point. So I simply click on the new layer, and then I simply use here the vegetation. So I simply use here the vegetation. Okay, in this time I simply use here the feature collection and property. So I simply use here the property name is the class. Suppose for the vegetation I put the value is the 2. So all of the vegetation training point value is represented the 2. So in this time I simply click on the OK. Okay, for the vegetation, and then I simply, okay, wait a minute. Okay, so I simply take the vegetation, and then I simply take the some vegetation part in here. Suppose in this time you can see I did not find the vegetation in this satellite images easily. So then I can also use here the another technique. So it's called the different types of band combination. So I can easily use the different types of band combination from here, and I can easily identify the different types of feature. So you can easily, I will provide you a website. This website is that. This website, mainly from this website we can easily identify the different types of band combination, and using this band combination we can identify the different types of feature. Suppose you can see this is the natural color 432. This is the red, green and blue. It replicates the close to what our human eyes can see. Healthy vegetation is green. When you want to this band combination, then healthy vegetation is showing the green. Unhealthy flora is brown. Urban feature is white and gray, and water is the dark blue or black. Okay, dark blue or black. When you want to use this band combination, when you want to use this band combination, you can see 543. This is the near infrared band, red band and green band. It's mainly useful for the vegetation analysis, where and it's showing the area for the better or healthy vegetation, showing the health red color. So when you can see this is the red color, it's identify the better vegetation or healthy vegetation, and dark areas are water and urban areas are white. Suppose I want to show this band combination, so I simply go to my layer, and then simply click to here, and then I simply use here the 5 near infrared, then 4, this is the 5 4 and 3. So I simply 5 4 and 3 and click to the apply. So now you can see what is the looking. So in this time here you can see the healthy vegetation is showing the red color, water is showing the dark color. You can see this is the water body, also you can see the water body. So in this time I want to simply identify the some vegetation area. So here you can see the vegetation, this is the red pixel value. I simply take the red pixel value, okay, from here. So this is the vegetation area, also some vegetation in here, okay. So I can easily identify using this band combination where is the vegetation is located. So I can easily identify using this band combination, okay. Okay, and you can see there are a lot of other you can see, also you can see this is the another band combination for the near in short wave infrared 2, near short wave infrared 1 and red band, okay. This composite display the vegetation in the shades of green, while the darker shades of the green in the indicate the dense vegetation, okay. Sparse vegetation is the lighter shades. Urban areas are blue, and soil have the various shades of the brown. Also you can see when you want to make the agriculture identify agriculture area you want to identify, then you can use this band combination. So it mainly used for the crop monitoring, okay. and we can easily identify the cropland. When you want to use this band, we can easily identify the cropland. Also you can see this is the geology band combination, this is the bathymetric band combination. Okay, there are a lot of band combination. Also you can see NDVI vegetation band combination, or moisture index. Okay, so we can use the different types of index, or different types of band combination for identify the different types of feature. Okay, suppose when you use this band combination, then we can easily identify the agriculture feature. When you want to use this band combination, then you can easily identify the different types of vegetation. When you use this band combination, then you can easily identify the vegetation. This is the red color. Okay, so and dark areas are water. Okay, like this. So there are the different types of band combination. When you want to make the land cover classification map in the unknown place, then you can simply use these different types of band combination or different types of indices. Then you can easily identify the different types of feature, and then from the feature you want to take the training point, like this. Okay, in this time I also take the another classes. Suppose this class is that barren land, so I simply use here the another training point. Sorry, barren land. So in this time simply use here the feature collection, and property will be same for the class. And in this time all of the barren line training point I want to show, this is the value is the 3. Then click to the OK. So I simply take the some barren land from here. Okay, so in this time I want to run my, you can see this is my third process. My third process is that uh, take the training point. Okay, so you can see our slide which I want to already discuss. You can see this is our slide, step slide. First of all I selecting my ROI, then choosing and filtering my image collection and collecting the training point. Okay, so this 3 step is already done. In this time I want to show you that how you can easily merge all of the training point. So it's very easy. So when you want to merge all of the training point, we need to help the feature. So merge function. So in this time I simply use the merge function, and then I simply merging all of the training point. So for this I simply take a variable. Suppose this variable name is the training. You can use any name, no problem. In this time I simply use here the all of the training point merge. So first time you can see water, I simply use here the water. It merge with suppose build up. So I simply use here the build up. Okay, then it also merge with vegetation. I simply use here the vegetation. It's also merge with barren land. Okay, so I simply merge. In this time I want to check what is the condition about this. I simply use here the print, and then I simply copy, just you can see I simply copy this variable name and paste here, and then click to the run. In this time you can see I take the total 132 training point. I take total all of the classes. I take total 132 training point, and you can easily identify. You can see for this training point, you can see properties. You can see class 0. So you can easily identify what is the training point for the 0. 0 value is for water body. You can get all of the value. You can see what is the training point for the this value. You can see 3. So 3 is the, we can already know about the 3 is that barren land. Okay, so it will all of this is our training point, all of the training point with their classes, class value. Okay, with their class value, you can see 0, it identify. Also you can see another training point, suppose what is the value, you can check, you can see this value is that 0, so it's also training point for the water body. You can check what is the value, you can see this is the class 1, so this is the value for the build up area. Okay, so we can get total 132 training point. Okay, in this time we need to make the training data set, and this training data set make from the pixel value of band. Okay, suppose in this time I want to use the pixel value, and I want to take every is point, all of the band value. Suppose you can see this is a single band, this is the single point. I want to need or for only for this point, or only for this training point, I want to need all of the band value. Which band value I want to set here, all of the band value I want to need. So here you can see total 132 training point. I want to need all of that band value for total 132 training point, all of the band value. In this time I want to set here the which band I want to need. So I simply, in this time I simply show you that training data, how you can easily make the training data. So when you want to create the training data, I simply write the comment, create training data. In this time, first of all, you need to create a label, then you need to select your band. Okay, so in this time I simply take a variable and give the variable name is the label. Okay, and what is the label? I simply put the label name, my property name, which property I want to use here. You can see I use here the class, so this is my label name. So I simply copy and paste here. After this, I want to also need to the band, which band I want to work in this time. So I simply take the variable bands and make a list. I simply use here the square bracket, then I simply put here the b1, I put here my b2 band, also put here the b3 band, also put here the b4 band, also put here the b5 band, also put here the b6 band, also put here the b7 band. Okay, so you can see I want to create it the band, all of the band in this time in here, and put here this band. Okay, in this time you can see I want to need all of the band value for total 132 training point, all of the band value. Suppose this is the point, what is the band value for the b1, b2, b3, b4, b5 and b6? What is the band value for this region? Okay, what is the band value for this region? All of the band value I want to create this for total 132 images, and it's called the training data set. Okay, so in this time I want to take the training data set, and in this training data set, what is my input? My input is that I simply take the variable input, and then I simply use here the call my image. So you can see this is my image. I simply copy this image, and then I simply use here this image, and the select, my input is that select this band, which band I already make the list. I simply select this band. In this time, this is my image, this is my full collection. This image select the bands, and this band already stored my requirement band, which band I want to need. I already requirement it. Okay, in this time I want to overlaying the points on the image to get the training data. So in this time, for this I simply use it using the sample region function, sample regions. Okay, so in this time I want to show you that. So I want to make the training data set for each point. Each point I want to generate all of the band value, every individual point. So for this I simply take a variable and give the variable name is that train image, train image, and then I simply call my input, then paste here, and in this time I simply use a function sample regions. Okay, I put, oh sorry, so here you can see I can get all of the argument. I simply make a dictionary. So I simply use here the curly bracket start as well as curly bracket int. Okay, and then first of the collection. So this is the keyword, and what is the key value of the collection? This collection keyword is that training. I want to make the training from here. Okay, then properties name. What is the properties? Properties name is that I already defined the properties name. Properties name is the level. You can see this property name is the class. Okay, I stored this class value in the level, so I simply use here the level, and then I simply write here the level. And scale is the resolution of satellite imagery. This is the 30-meter resolution. Okay, so sorry, this is a 30-meter resolution, and the projection not needed. I simply remove all of the things. I want to simply use here the print function and then call the train image. So in this time here you can see what I can get from here. I get every individual training point, get all of the band value. So here you can see. You can see for this point you can see 0. I want to get the band value all of the class 0 for this point. For the 0 number training point, it represented the class 0. It means that water training point. I take the for the water training point, I take all of the band value. I get all of the training band value, and do for the same thing all of the training point. I can see, you can see for the one, for the training point 1, it represented the build up area, and this is 37 number of training point. Here I can get all of the band value. I can get all of the band value, total 132 training point. I can get all of the band value. Okay, you can see I can take the all of the band value. Okay, you can see I can the all of the band value. Also you can see I take the all of the band value. Okay, in this time suppose you want to add here the some external band. In this time I want to use only for this band. You can see I want b1. This is the ready-made band. Okay, in the satellite imagery. If you want to make the land cover classification map for the another external band. Suppose you want to use here the ndvi band. Suppose you want to use here the ndwi band. Suppose you want to use here the ndci band. You want to use here the build of index, or different types of band will be available here. So then your land cover classification is more accurate. So you can easily add this. Suppose you want to create a, in this time you can see this image, this image only showing the band. Which band in this time is showing? This band, you can see this is the ready-made band. All of the band is in here in this image. But in this time I want to also add here the some extra band. Extra band is that I want to created the ndvi band, and I want to use this band for get the value for the every every training point. I want to need the ndvi value. So that's why my map will be good accuracy when you want to use the ndvi, ndwi, or other things. Okay, then you also need to create it the band for external band. You want to create it for do this. Okay, so it's very easy. So you can easily make the external band using the function, and then you can also need to use, suppose when you want to add here the ndvi band, you can simply put here the ndvi. When you want to use the ndwi band, you can simply put here the ndwi. Okay, when you want to add here the build of index band, you can simply put here the bi or ndbi, in normalized difference build of index, and lot of index will be available here, and every specific indices for take the value for the, for suppose you can see ndvi, this value range is the positive 1 to negative 1. In this time the positive value is identify the vegetation, and negative value is the identify the non-vegetation. It can be urban build up or other things. For the NDWI is the same things. The positive value for the NDWI identify the water surface, and negative identify there is the no water. And do for the same thing for the NDVI. Positive NDVI is represented the build up index, and negative NDVI is represented the non build up index. Okay. So in this time here you can see, if you want you can also add here the lot of band, which band you want to need. So in this time I want to show you the one band. Suppose I want to add the another external band for the NDVI. So that's why it's also showing the NDVI band. So then you can easily apply this formula or a method. You can also add here the which band you want to need. You can easily add here the NDWI, NDVI, any band you can easily do it. Okay. So for this, when you want to create it, the external band, then you also need to work with this function. This function is that I write the function in here. Suppose I simply use here the function and give the function variable name is the add ndvi. Okay, add ndvi. Then I simply put the element name is the image, and then I simply use here the suppose curly bracket, and I want to simply put here the take a variable and give the variable name is the ndvi, and then I simply use here the image. Then I use here the normalized difference function. And what is the normalized difference function? Between the near infrared band as well as also need for the red band. Okay, so I want to calculate it the ndvi, and I want to add the ndvi band. Okay, so I simply use here the return function, and then I simply call my image element name and add bands. Okay, add bands. I simply add bands. And what is the add bands? This is the ndvi. Okay, I also rename this, so I simply use here the rename function, and this is the ndvi band. Okay, I changed the name. In this time you can say I created this function. I just add this function with my map in here, so I simply use here the map function, and I simply copy the variable name. So now this ndvi band is also added with my whole collection. If you want to need the ndwi, you can do for the same function and put here the ndwi. If you want to need the build up index, you can simply do this. Okay, this is the same process. And I want to add the ndvi band. When I click to the run, okay, so in this time I also add here the ndvi band. I simply remove this. Okay, so when I click to the run, you can see it's also showing the ndvi value. So you can check what's happened. You can see for this point I also get the ndvi value. You can see this is showing the negative, so you can easily identify there is the no vegetation. Okay, so here you can see and this class is the 0. We already know about the class is the 0. It means that this is the water, and water ndvi value is the negative. We already know about that. So I can get all of the training point. I also get the all of the training point negative value. You can see not negative value, I also get the ndvi value. Okay, you can see I can get all of the ndvi value. So in this time my training data set is the more strong. Suppose you want to add here the ndwi, then your training point will be more strong. When you want to add here the build up index, your training point is the more strong, and your map will be more good, or your map will be more accuracy is very good. Okay, so in this time I also try to show you the one for the one band, how you can easily create the external band. Okay, this is the external band, and all of the things will be internal band. Okay, in this time I simply work with this, and I also add here the another band. This band is the ndvi band. Okay, this is the another band for the ndvi band. I want to add this ndvi band. Okay, so this is my training data set. Okay, I created this training data set. In this time I need the I get the total training data set from here. In this time I want to divide this training data set two things. First thing is that I want to convert the I need the some training point for the training my model. I also need the some point for making the validation or check the accuracy assessment about this accuracy. Okay, so in this time, so accuracy, mainly we can use the accuracy for checking the model is good or bad. Suppose in this time here I use the random forest or classification regression trees, minimum distance, or whatever, what classifier I want to use. I want to check the model using the accuracy. If the accuracy is the good, then model is the good. If the accuracy is the bad, then model is bad or not good. Okay, so in for the checking the accuracy, I divide this dataset two way. So first way is that I want to take the training data. Suppose you can see this is my total training data set. This is the total training data set. Train image is stored at the total training data set. In this time, I want to divide this data set two way. First way is that I want to take the training data set. Suppose I want to use the 80% data set for train my model and 20% data set for checking the validation. What is the accuracy of this map? Okay, so in this time we want to use this. So if you have any question about this, you can ask me. Any question or any doubt about this code, anyone, you can ask me. Any question, any doubt?
No question. You can carry on.
Okay.
I have a question.
Yeah, ask me.
When you were doing the, can you go to the code, please?
Yeah.
Can you go to the code up, because you use the median to when you were writing the code instead of using mean. I didn't understand why you choose median in this case.
Why are choosing the NDVI?
No.
Yeah.
At the beginning, when you start, can you put the your engine script? Can you go to your code? Because right now I don't see anything. Yes. Upstairs at the beginning of your code.
Yeah.
When you were filtering here, when you were filtering, you just after the when you had the MDPI, you used the median in this case. I want to understand why. The median.
Okay, median.
Yes, downstairs.
Okay, I understand
Yes,
your
yes.
question.
Why you use median?
So in
Yeah.
this time, if you want, you can use the every single images. Suppose when I want to run this code, you can see. I also check it. Wait a minute. So you can see here I can get total images. Here I can get total 7 images. Okay, here I get the total 7 images. You can see this is the total 7 images I can get. If you want, suppose you want to work only for these images, only you want to make the land cover classification map using only for these images. Okay, then you can
Okay.
simply use this single image, no problem. You can simply copy this ID and work with this image. Okay, then you can ignore the median value, then you don't need to the median. In this time what I want to do, in this time I want to create it, I need the total 7 images. You can see this is the total 7 images. From this total 7 images I want to take the median value, median pixel value. From this total 7 images I take the median pixel value and I created the image of the Landsat image, and then I want to work with this. Okay, in this time if you want, you can simply copy this image ID. Suppose you want to need only for the image, which image the capture the year of 2020 11th February, you want to work with this image, then you can simply copy this ID and work with this image, no problem. Okay, in this time I want to create the median composite, median pixel value composite, and all of them will be same. Suppose you want to, when you want to work with this image, it will be also same. So this simply copy, and you suppose you want to show the image, so I simply copy, and then you need to use here, suppose I want to take the suppose variable and give the variable name is that suppose L8. Okay, I simply use here the L8, and then I simply ee dot image, and then I simply put, you can see this image, I simply put this image ID. So now you can simply showing the image in here. I can simply use here the map dot add layer, and then I simply use here the L8, simply call the L8. Okay, and it also clip with my shape file. I simply use here the clip with my ROI. Okay, and when I click to the run, you can see this image will be showing. Then you can take the training point from this image. You can see it will be showing this image. You can see only for this image it will be showing. Which image I want to show, it will be showing this image. So I want to use here the visualization parameter in here. You can see I want to use here the B4, B3 and B2, and click to the custom is the 98% and click to the apply. You can see it also showing the image in here. If you want, you can use the single image. You can work with this image is captured year of 2020 11th February. Okay, you can also work with this image.
No.
Yeah.
Hello. Yeah, I think you didn't got my question. At which moment we should use the mean? I mean, when we are supposed to know, we have to use the mean and the median.
So median in this time, there is the lot of way. When you want to make the filtering the image classification, you can also use the median pixel value. If you want, you need the mean pixel value. If you want to need for the mosaic, when you want to the median, it will be calculated the median. Total 7 images, it calculated the median pixel value and showing the image when you want to use the median. When you want to use at the mean, it will be calculated the total 7 images average pixel value and showing you the average result, average pixel value image. Okay, when you want to use the mosaic, it composite all of the total 7 images and showing the result. When you use the single image, yeah, so this is the different way when you want to make the showing the image classification. You can, if you want, you can use the median. You can use the mean. If you want, you can use the mosaic. Okay, if you want, you can also use the single image like this. Okay, I hope you can got the point.
Yeah, it's okay, I got the point.
Okay, okay, so we will try to again from here. So in this time, we also add here the external one band. If you want, you can also add here the another band, no problem. So in this time, we want to divided the dataset two way. Test data